All right, so what we're going to do now is we have to first of all go through the code and kind of get an idea about what it's supposed to do. So let me just start by saying that at the very, very bottom of the code, there's this one line here, which is it's all the way to the left-hand side of the screen here. Code in Python is spaced by tabs to indicate code blocks. Some people really like that, and some people really, really don't. I saw the tabbing system in Python. I thought it was a little bit unusual, but you get used to it. But basically what we have here, though, is this one line here, main, at the very, very bottom of the thing. This is what calls, this is after all this stuff has been run, this is what calls the functions. So first of all, when you run this, I guess I should say, when you run this, anything that's tucked away at the very left-hand side of the column, like for instance, this information here, which is just stuff that I add so that I have an idea about where this code came from. This is information that I had, that it's just standard in my code, so I can add color to my text. These are the definition, or these are the defined functions. Those were all loaded at the time of the execution of the program, but you can see that there's nothing in these functions, and there's nothing in this function either. And they're all loaded into memory, as well as this main function here, which is your kind of your driver function. But those are all loaded into memory, and they're all supposed to do things, but they can only do something when they get called. And so this is your call to main, right down at the bottom here, and main will then, or that main function here, will then kind of start running the program. One thing you'll notice, though, at the bottom of each of my pieces of code, and you don't have to do this, but you can if you want, that is that I add this end of main there so that I know kind of where the end of this function is, just to help me think things through. So let's look at what main is doing. The first line is just a basic print. This line over here, as you remember, is a doc string. It's like kind of a it helps you to debug this. If you're using some different types of editors, you can, when you list the functions of your program, you can see this statement here, and it just gives you an idea about what this function is supposed to do. It's the driver function. This is just a print statement, just drops down a line here, gives you some space. But here is a comment, and it says, ask the user to enter a sequence, or enter sequences. And so this program is an alignment-based program. And in fact, if you'd like, I can show you what it does before we actually build this thing, just so you have an idea in the back of your mind about where we're heading. And so if I just go ahead and exit this, I can show you what it does, which we're going to be building in class today. And it works like this, where it says, and that's this part up here where it says, we have the sequence information, enter sequence 1 and sequence 2. So I'm going to go ahead and enter sequence, and I'll call this ATGT, C, whatever. Sequence that it's asking me to do. And so what is that? That's from the other sequence. Sequence 2 is equal to getSeq. Now, I'll talk about those functions in a second here. Those are functions that I've actually we have to write those functions. But we have a function that gets a sequence. So now, once I've typed in the next sequence, I'll just put C, something like that, I don't know. Enter that. What you get is some information about the alignments, and you get, we're talking about we'll talk about what they actually mean in a second here, actually toward the end of class. We have global alignments, where basically you're looking at one sequence and comparing it to another sequence in its entirety to see how similar is one sequence to another. That's your global. And so you have information about the scoring, and we talk about the scoring and the algorithm on Friday, so don't worry about this just yet. But this part down here is talking about like all the possible gaps that could potentially be there. And again, we'll talk about that on Friday. But the potential gaps, like how do you actually put these two sequences back to back? I mean, how can they possibly go? And so you have all this, you have some interesting things that you can look at here. Then if you move down, you actually have the alignments themselves. And so this is my first sequence, if you can see that. And this is my second sequence. And so the program is trying to figure out like what parts of each sequence are common, are both common. Like what parts of each sequence are both common. And if they're common, you have that little line that's drawn there. And so in the grand scheme of things, this TC, if you imagine this is like a whole stretch of much, much more content, that could be a common region of genes or something between these two sequences. So anyway, these are just all the possible alignments that you could have. global, where you're looking at one sequence and another, kind of like how they are entirely similar. But then you have local alignments, which is a little bit different from a global alignment. And that local alignment is looking at actual chunks of individual pieces of code inside the DNA sequences, which are similar. So for instance, here, you can't really see this is a very good example. But what it's trying to do is it's trying to say, okay, well, how much content in each sequence, if it's grouped together, can also be found in the other sequence. And so maybe if I try a different sequence, let me just try something else like, I don't know, CAT, TTTTT, like that. And then I'll put to CAT. Those are my two sequences. You can see that, for instance, in your global, it's trying to analyze everything as like two different sequences. You can see that cat, which was like a far shorter sequence than the other, it's just putting a bunch of spaces in there, saying that there's nothing, these are just spaces. But whereas here, what it's trying to do, and maybe this isn't the best way, but it's trying to, you have shorter sequence results, where it's saying, okay, maybe there's a bunch of stuff in cat or in that shorter sequence, which is useless to this analysis, but there's a certain chunk of code which is common to the other sequence. And so it's really saying, I found these isolated pockets of data which are common across both of those sequences. Anyway, so now you have an idea about what this program is supposed to do. So let's get back and start coding this, and hopefully we'll be able to finish all of this today. Let me just go ahead and get back to my, where's my, I've just lost my editor here. There we go. So let's go ahead and do this. And so we have that part over here. So that's where we're going to be getting our sequence. And then down here we have two different functions that actually perform the global alignment, which is another function we have to write. And then we have this local alignment function, which is another sequence analysis function that we have to write. So let's go ahead and start with this one here, where we have to do the actual get sequence. So you'll see that this is actually a call to another function, and whatever this function does is return to this variable here, seek1. And then you'll notice that seek1 is then used to be sent to, is then sent to other functions in other places. And so we have to go back and find out, it's right here. So we have to find out how we can change this. Well, basically what we're going to do is we're going to use an input function here, asking the user to go ahead and, maybe I'll save this as something here, so I don't want to write over this just yet. We're going to ask the user to enter a particular, and by the way, you might want to save this somewhere else, because if you save this into your class docs repository, then if you remove your class docs repository, then all of your code is changed. And so you may want to, and you can work with it here, but be sure that you move this file out, or copy this file out somewhere else, a copy of this. All right, so what I'm going to do is I'll start working with this. And so what we're going to do is I'm going to have I type in what's called I have to make another string here, and I'll say enter the sequence. And so this is just I'm making a basic, this is just a variable. And when I make my variables, I always have this underscore, well, not always, but I tend to have this underscore str. That tells me that this string this is a variable that's a string. It just helps me to kind of keep tabs on what everything is. And the idea is that when you're working with code, and there's like a lot of stuff going on, if you see that this is if you see this variable, you just know that this variable is a string, and so that informs you about how you can go ahead and write, or how you can write code for that variable. The next thing I'm going to do is I'm going to make another variable, and I'm going to call this input sequence, and that again is another string. And I'm going to call this, and I'm going to call this function here called input. And input is then going to, let's go ahead and write this out here, prompt string. This is going to basically say, user, I'm waiting for you to say something. And whatever you say, whatever you type in is a string. And then this is what I will tell the user, this string here, this prompt str, this enter the sequence is what the user is going to see. And then they're going to be prompted to enter something in, and then whatever they enter is going to be saved to this. That is your string that comes directly from the user. So then what I have to do is I have to now I have the string from the user, but this string is it's only here. I need this string to get back to this function here. You see this one here. What I need to do is I need to return that string. Return input str. But there's something else that I need to do for BioPython, and that is that BioPython doesn't like working with just regular strings, but rather BioPython likes working with its own data structure. And so what you have to do is you're going to take this string that you've just got from the user, and you're going to wrap it inside this function that comes with BioPython called seek. And seek is going to convert this string into a sequence. Now, the reason why they would do that in BioPython, why would the developers write a piece of code that would change the string? I mean, what's more general than a string? Well, you may have other information which is necessary for BioPython to function, and so maybe it needs to somehow alter the format in its own way or makes things more efficient or whatever it may be. But this function here, seek, does that. We don't have to do anything. And so now this, the whole getSeek function should be complete. We're giving the user some kind of a message here. The message is then being used in an input function, which is asking the user for some kind of input. And then whatever the user types in, which is this, is now being wrapped up inside this seek function, which is then converted by BioPython so that it creates something more, I guess more efficient for the program to run with. So I'm going to save this. And if I go back to, if I can go back to my prompt here, I think that we can kind of see what it looks like. And so I've actually saved this as this file here, _i. And so if I go ahead and type in Python 3, hopefully this will work. BP align coding in class _i. I'm just doing that so I have a version on the end of it, but that's really all it is. I already have my function here. It says enter sequence, and I can type in anything I want. Hello, hi. And so it doesn't really matter. The thing is though that it does pull a sequence. It does pull a sequence, and so you have this information. Now, the next thing we need to do is we need to work on these two functions here, the global and local alignment. So that means that going back to this code, we have already been able to pull over the sequence, but notice though that going back down to main, this function here, global alignment, is being called where these two sequences are being sent, but nothing, looking at our output here, nothing is actually happening there. They're just sitting there. So we need to flesh out that code too. But it does work though. The code does work. And the nice thing about Python though is that you can run the code as you're developing it so that you can kind of see if there's any bugs. And if there are any bugs, in fact, let me just show you something. Let me go ahead and introduce a bug in my code. As you can see where I'm working now. I'll just put, for instance, input with two T's, for instance, if you can all see that. If I save that, let me just show you what will happen. I can go back to my editor or my terminal. If I run this, you'll see that I get an error message. Now, I will say that working with students in Python for some time, one thing I've noticed though is that when people see this error message, they tend to freeze and they tend to kind of like, oh no, it's not working. Don't panic. Never panic. Just look at the error message and see what it says here. At the very, very bottom, it says name error. Name input is not defined. And where's that lack of definition? That's at line 56. The rest of this information here, which is confusing, and I will admit that when I first saw this, I was kind of taken. I was kind of freaked out by it. But this is what's called I guess the follow through, or how you got to this error. First of all, you would code at line 110. Then you would code it at 86, and then you would code at 56. And then in 56, there's this function here called getSeek, and inside the function getSeek, you find that there's this error at that line. And so let me go ahead and just go back to the editor, and if you go to line 56, that's right here. And so I guess the bug detection system in Python is actually very effective. You just have to read everything and don't panic when you see a whole bunch of errors. And sometimes, for instance, when you get an error, there's like a whole page of stuff that's coming out at you. But again, that's just giving you the kind of the flow of how you got to that error. At line 56, if I just go ahead and change the line error, and then I go back to, if I can get back to my code here, and if I run this, you'll see that it should run without any sequence trouble, or I actually get the sequence, but I shouldn't have any. So I guess the message is, when you first see these errors, though, they can be either a little bit confusing and perhaps a little bit upsetting. I know that, for instance, I have had my share of being upset by some of these errors. Actually, they're actually quite logical and when you just look at the line number. Okay, so the first thing I'm going to do now is this down here, by the way, just gives me it just drops a line here to give me some space. it's easy to kind of visualize what the output is. And the next thing I'm going to do is I'm going to go onto this global align, this function here. And so that function is right here, if you can all see this. Notice what I'm doing. Every time I do this, I'm going to be removing these to-do lines because to my eye, when I see to-do, that suggests to me that something has to be done. But here I am working on this. This is actually a slightly different kind of print statement, but it's still a print statement nonetheless. What this is doing is I have this bi yellow plus. So this is actually a piece of code which I define up here. Where is it? Somewhere. Here we are, this one. It's a piece of code that I define right here that just basically, it tells Python, make the text yellow. Make the text yellow. And that's where, for instance, this text here is coming from. That's why it's yellow here. Now, I like to do that because when it's late and you're working with sequences and all this information is flying across your screen, sometimes if you have color, it really helps you to kind of understand. And so we can add some color to the getSeq statement later on. But in the interest of time, I think I'll just keep on going through with this. But you can do this at home if you want. You can add seemingly any of these colors up here, and I've put the colors in the comments, and so you can kind of get an idea. And you can add those colors to your code here, and so that might help you to visualize what's going on. So here we are. So I'm saying, okay, set the next part of the text. I want to be in yellow, and then I have to put this little plus here because this, after all, is a kind of a string. And this is another string, and so I'm really kind of adding together two different strings. And so that means that yellow means that all this code right here is going to be, or this string is going to be printed in. I have to switch it back to white because I don't want everything yellow. I just want that particular piece yellow. So my code for my global alignment is going to be actually kind of, it's not too bad here, but I'm going to be called my alignments. I have to make another variable here, and I'm calling what's called the pairwise function, which exists from BioPython. So I'm going to say my alignments is equal to pairwise 2. I guess there's a pairwise 1 at one point here. Align dot global, and then we have this is kind of a strange thing here, is XX. And then inside here, I have my two different sequences. So you have my alignments. Hopefully you can all see this. It's not very clear. I think it gets better. I do apologize if this is not very clear on the screen. I will release my code so that you have it. So if you just can't see it, then you'll have my code later on. But if you can't see it because of Zoom, then I do apologize. But really the code says my alignments. In fact, maybe I can make this a bit bigger. Maybe that would be helpful. My alignments is equal to pairwise 2.align .global xx and then I'm going to put my two sequences, sequence 1 and sequence 2. But before I go any further, I want to ask myself, where do these sequences come from? Well, they come from here. Sequence 1 and sequence 2. So what's going on in main, and I'll leave this up for a second here, but I'll just talk you through it and then we'll see the code. I can see that some people are still working on this code. But what's going on here is that when main calls this function here, global align, what it does is it sends two sequences. In fact, let me just go down and show you. Global align, it sends sequence 1 and sequence 2. These two sequences, sequence 1 and sequence 2, they're really active in this function. They're really only active in here. So that means that if I didn't send these sequences to get global alignment, then they wouldn't be there. So that means that every function is kind of stingy and kind of selfish, and it has its own copies of these, these variables. And just because main has copies of sequence 1 and sequence 2, it does not mean that these other functions have sequence 1 and sequence 2 unless you send them a copy of sequence 1 and sequence 2, which is exactly what this is doing here. And so now, get global alignment has sequence 1 and sequence 2, and so they can, or so this function now can go on and use it. So we have this alignments here. And so the next thing I'm going to need to do is, I'm just going to go ahead, I'll just print the alignments here. Print my alignments. You can see what's kind of going on. And that's where all that other information came from about the scores that we'll discuss on Friday. And the next thing I want to do is I need a for loop here. And I want to go through each of these alignments here. For this alignment in my, oops, I don't know what that's all about. in my alignments. Now, what's going on here is that my alignments actually is a kind of a list where you have all these different things that are separated by commas. And so what I'm doing is I'm using this as my index. I'm saying for this particular line, in all lines, iterate through these lines and show me what this particular line is doing. It's basically what the for loop is saying. But if you just type in like print, if I just type in print this alignment, then you'll see kind of like what's going on with that. So I'm going to go back now. I think that this is working out okay. I'm going to go, I'll save this. I'm going to go back to my, we'll come back to the code in a second here, but let me just go ahead and check it to make sure that it is working. And if I go ahead and run this, and I'll just type in ATG, C, AAA, whatever, you can see now that something is happening. And what's happening is, I'm not looking at the results just yet though, but what I am looking at is that, for instance, my code is working and doing what it's supposed to do. And that is, I'm expecting to see all this stuff that's here. It's performing the alignment. And so it actually is working. And so you can do that. As you're working on your code, you can actually go through and check to make sure that the code is running midway through, which is extremely handy. This is something that you cannot do in other types of programming languages that have to be compiled, especially if you're working with like C++ or something. You have to compile the code each time. Okay, what we're going to be doing here, I'm just going to like change the color here. You can just try this and see how this works. Okay, this is going to change the color, and I'm going to go and do another one of these for loops. I want to iterate through all my results, but I'm not just going to be iterating through my results. I want to actually iterate through the actual alignments themselves, the graphical, so-called the graphical alignments. So we have, for this alignment in my alignments, there we go, that's the variable that I used. This is a kind of a strange way to put this here, so prepare yourself. Print, I need to format the alignments with the graphics. And that command is format _ alignment. And then inside here, that's another function that's built into this is a function that's built into BioPython. Inside this function, I need to send it some more information, and this is just madness. It's like star this alignment. And so hopefully that makes some sense. I'll move this up here so you can see. But it's this code here. That doesn't make any sense at all. But this is, I mean, it is Python, sure. But this kind of code is BioPython. So BioPython's developers put this together and they said, if you want the actual kind of, the graphical output of your alignments, you have to use this code. And so whatever they say is fine with me, as long as it works. Okay, I'll come back to this code in a second. Let me just go back and test this to make sure that it does actually do what it's supposed to do. And so if I run this again, I'll put in, for instance, ATG, and I'll just put TG. Oops, I have an error message here. So what's going on? I guess I have to go back and fix something. So what could be the error message is that I need to add another library. And the library is from .pairwise, I think it is. Import this format alignment. So you have this library that has to go there. That makes sense because, for instance, this is an actual piece of BioPython technology which is being kind of used in my code, but the code doesn't have it. It's not, I mean, this code is not just floating around in the BioPython library is not just floating around in my code until I actually bring it around. And so let's try this again now that I've added this from bio.pairwise2 with a capital B. Capitals do make a difference. If you're having some trouble with your code, capitals make a difference. Import this library from this package here called bio.pairwise2. I'm going to save this. I'm going to go back to my command, and I'm going to run this and see what happens. Okay, and I think that I have to actually change my color here. There we go. It does work. It does work. So that is, this whole code here creates this alignment, which is actually quite cool. ATG, AT, whatever it is. GTG. I'm just making some codes up here, but again, you can see kind of how it's trying to. It's actually offering an alignment which is rather similar to, if I go back to my slides for a second, it's this. We're actually giving ourselves this information here. So that's actually really cool, I think. Okay. I don't mean to make you dizzy. There we are. Let's go back to our code. And that's basically that for this. And so what I'm going to do now is I need to set, because I changed the color up here to cyan, I'm going to go back and change the color down here, not to cyan. Make sure that your spacing is correct. It's like you're not tabbing where I'm not tabbing. I'm going to change this back to just regular white, and that's what I call the system color, so that it doesn't change everything. Not everything is printed in cyan from this point on. So all this stuff is in cyan color. So this is done. So we have now finished our get global alignment, which is finished. So the next thing we need to do is go back to our main and find out what else is there going on. So this is all checked off. That's good. Oh, and then we have local alignment that needs to be fixed. And so local alignment, I can just give you the heads up here and tell you what it is. But local alignment is actually very, very similar to the global alignment. In fact, I'm thinking that what I could do is just copy some of this code, starting from up here. I'll just copy everything, and then we'll do the code, and then we're going to go back and modify the code so that the local function works. So I'm going to copy that. I'm going to go down to my local function. And by the way, are there any questions that anyone's having here? Hopefully everything is working for you on your end. Is everything working? If it isn't, don't worry. I will give you this code so that you have it, so that you can kind of see, you can compare your code with my code. Now, one thing I will say though, that when I copied it, I had this error message where all of my code was indented. I can't have that. So what I'm doing, I'm using Atom here. And if I push, I think, my Shift and my Tab, I can move all these things back so that my print statement and my alignments and the other print statements and for and all these other statements here are all basically on the same line going down the column here. That means they're indented exactly the same way. I think that all I need to do with this, let me just look at this for a second here. All I need to do is this is the function that does global alignments. Can anybody think what the function might be that does local alignments? Yeah, I'm just gonna change that to local. I think that's all it is, and I think that's it. So I've just changed this line here, which says global to and I'm saving it. So now I'm going to go back and I'm going to see whether this actually runs. So I'm going to go transition to this over here. And I'll just type in ATGT G, I guess, and then I'll put GT, something like that. And as you can see, it worked, surprisingly. This is actually a very good example to show kind of like the differences. I'll go back to the code for a second here and give you some time to look at this. But as you remember, though, the only thing that I did was, from Catherine Burgess's, from your idea here, just to change the global to local. Just change that. Is this just the one line that I've changed? So you have this code up here, global, where this over here says global, and then you just copy all this code here, and then you change this global to local, and then it suddenly works locally. It's very convenient. I know that there's a bunch of like what I call setup fees when you have to time that you have to spend, setting this thing up. You have to pay for time as you're creating this code. But after a while, you can copy and paste things, and it seems to work very nicely. Okay, so let's get back to this. I'm going to go ahead and just get back to the actual output and give you some ideas about what to expect in this whole thing, like what we're looking at. So if I can get back over here. So the big difference is, and I'm hoping that it's kind of you're noticing this for yourself, but between global and local, is that global is saying it's treating each of these sequences as wholes. It's like it's saying I can't cut anything in these sequences. I have to align each sequence with another sequence as best I possibly can. And so even though one of my sequences, which is just GT, was very, very short and much, much shorter than the other sequence here, ATGTG. It's much, much shorter. When you're using a local or a global alignment, you're basically filling up the shorter sequence with a bunch of spaces. And you're saying, how similar is this sequence to the other sequence? Well, not so similar because there's a bunch of spaces. And the thing is, though, that you don't know what this missing information was. It's just missing information. You don't know what it is because you didn't have it when you first entered the sequence, but you really don't know what it is. And so global alignments doesn't know what that is either. And so it just says, well, I'm just going to treat that as a space and a space. And so therefore, this sequence as it is with the other sequence as it is, they are different. And while that's okay, you can do that. That's you can work that way. There's another way of looking at your sequence alignment, and that's called local, where local is saying, there's a bunch of stuff in the sequences which is different, but I did find there's a pocket of stuff in one of the sequences which is exactly the same or very similar to the other sequence or pieces of sequence. And so now what it's looking at here in local is you're looking at subsections of that sequence and trying to find out what subsections are common. Now, depending on your application, local or global, you may have different types of, in fact, maybe I go back to my slides and refresh your memory. If I go back over here, I'm not sure why I can't just transition easy. And let's see, why is it that you can't see me on this? There we are. There I am. Not sure why I'm not sure why my main camera is not working on this. I just don't understand this. But if you look at over here, if you look at this picture here, when you look at like the global alignment, you're looking at one giant sequence compared with another giant sequence. The whole thing is being compared. Both sequences, every piece of it compared. Now, when you look at the bottom here where it has local alignment, you're actually looking at pieces of those sequences, like sub-chunks, if you will. That's not a very scientific term, but pieces which are similar. And so you're saying that while I have two sequences here, and much of the stuff is not common, I do find, for instance, that there are some areas which are exactly the same. And so you're looking at, if I can find my terms again, over here, you're actually looking at these particular chunks, which are very, very similar. You're saying, okay, well, I found that GT is found in the upper sequence, and it's exactly the same thing as the lower sequence, so therefore that's this subsequence which is the same. And so local and global give you very different types of information. They're both alignments, but the global is saying look at both sequences together, and whereas the local is saying look at the pieces inside the sequences and compare those. Now on Friday, what we're going to be doing is we're going to go through and see what those, see how the algorithm works for. It's the Needleman-Wunsch, so that's going to be your global alignment. I think that's enough. I mean, once you see how that works, then the local alignment is very, very similar. It's just a slightly different setup, but it's the same algorithm. And then you'll have an idea about how this is all working. Let me go back to the code. Now, one thing I'd like you to do, if you would, is I'm going to go ahead and put out, there's an activity for today, and I'd like you to spend some time actually playing with this code. I can put out the code that we've just written in class today, so that might help you. But I want you to go through and run this activity. In fact, I'll go ahead and find this activity. Where is that? Shoot, where did I put that? I'll put the activity out in, why is that not showing up here? So many things to click on. Shoot, where is it? Ah, here we are. It should be in your, actually it should be in your sandbox. That's what it is. So it's this activity here. So if you can see that, you'll have this link, and I'll put this link out in Slack so that you have this. But if you go to this link, you're going to find, in fact, I'll just take you there and show you what to expect. You're going to find some experiments I want you to do, basically just to run through some code of your own, and hopefully if I can log in, I will. Oh God, I can't log in. Well, go ahead and click on that thing, and I'll get this under control, and then you can, and then we'll talk about the questions in a second. Let me just go ahead and do I have this actually written anywhere? Let me go ahead and put this on Slack so that everyone has it. Of course, I read my. Here we are. So I do have it. And by the way, on Slack, let me just say something. You do have a, there's a channel now on Slack. If you can, I can't show you my Slack here, unfortunately, I have to configure this. But you have in Slack for Bioinformatics 300, a channel called assignments, and hopefully you can see this. Hang on. Actually, it's activity. Activity 5. Is that where we are now? Goodness gracious. Activity 5. And so your activity 5 should come out now, but really it's, I'll just put this out as a Slack channel so that you can see kind of, I mean, don't write anything there necessarily, but that's just going to be like a listing of all the stuff, all the activities, so that there's no miscommunication, so that you know if anything's come out. So go ahead and find your assignments channel in the Bioinformatics Slack channel. I'm not exactly sure if that makes any sense or not, but spend some time actually going through this. In fact, I've been able to pull this thing up. I've been able to pull up the activity, so it's right here. And so basically, this is what you'll see. You'll see, for instance, you have to add your name, but it's going to be asking you to look at these sequences and then paste the resulting global alignments with the best score. And so one thing I'll say, though, that I didn't mention about this before, that is that when you are working with your alignments, you'll notice that there's this piece of information about the score, which is right here. On this area right here, you'll find if you have a bunch of different alignments, different possible alignments, which all satisfy the algorithm, you'll have a score. And some scores are going to be better than others. And so typically what you want to do is you want to find the highest score as your, and that'll tell you that that's your best alignment. So anyway, I think I've said enough. I'll let you discover the rest, but go ahead and spend some time looking at your activity, and we'll go from there.